of what we are going to present today. Next. Okay, first thing first, our company profile. Starting off with the company profile, Trust Maju Consult Sdn Berhad is one of the leading consulting and integrated engineering services company in Malaysia. Having been established ever since 2007, our corporate provide multidisciplinary integrated engineering services, which is civil, structural, geotechnical, and other related engineering discipline for over 14 years. We embrace innovation to provide clients with innovative, sustainable applications and livable solutions solving the infrastructure and urban challenges. We work with different clients with diverse type of project, which include aviation, tall buildings, water, roads, and highway. We are very proud to be the designers and consulting engineers with an impressive track of record of designing some of the Malaysia's most iconic landmark, which includes major projects such as KLIA International Airport 2, detailed design of construction supervision for package EF01, Penang International Airport, Sultan Abdul Aziz Shah Airport, East Coast Rail, Link ECRL, Kuala Lumpur City Centre KLCC, and Kuala Lumpur Central Station. Next. Okay, TMC is led by a team of experienced professional engineers with team members registered and accredited with professional bodies such as Board of Engineers Malaysia and Institute of Engineers Malaysia. We have IR Nazri Waihama as the Managing Director and the Project Manager for this project. IR Alia Afika as the Structural Engineer. IR Nur Hafiza as the Main Infrastructure Engineer. IR Mizar Danish and IR Awad Ahmad as the Road and Runway Engineer. And lastly, IR Chipepe as the Geotechnical Engineer. Next. Okay, for this project, the proposed location is at Lot 2387 Sidam Kiri, Kuala Lumpur with a land area of 270 ha. The land status for this project is Saim Plantation, which governed by the authority of Majlis Pemadaran Sungai Petani and PSK. Based on the Rancangan Struktur Negeri Kedah 2035, a domestic airport is going to be proposed for future development, which is the Kuala Muda Kulim Airport. Next. Okay, we move to the project objective. We Trust Maju Consult are the consultant for the project, which is the cadangan membina. I think sebelum ni. Okay. We are consultant for the project cadangan membina lapangan terbang domestik di Lot 2387 Sidam Kiri Kuala Muda Kedah yang mengandungi bangunan terminal, landasan kapal terbang, tempat parkir kenderaan dan kemudahan lain-lain. And the contractor, surveyor and the M&E engineer are stated as in the slide. Next. Okay, for our project objective, as this is the domestic airport, which is designed in line with the state government of Kedah, which intends to develop and establish a new domestic airport for the northern region. For the northern region with a vision that this airport will serve the state of Kedah, Penang, Perlis, Perak and other states. And the existing domestic airport, which is the Sultan Abdul Halim Airport, is already 92 years old and can only handle 0.8 MPPA at the time. So the state government of Kedah intends to develop a new domestic airport that can accommodate more than 0.8 MPPA. All these purposes are in line with the Plan Pembangunan Kedah 2035, which the construction of the domestic airport is part of this plan. And for the traffic statistic, we can see that the starting from 2012, the passengers handled by the we proceed.
That's quite scary.
Yeah. Takut nanti macam terbakar seplak. Okay, we proceed. However, the number of passengers... semua laptop okay kan? Okay. However, the number of passengers dropped in 2020 due to the pandemic, and according to Malaysia Airport Sdn Berhad, As the endemic phase and the Pelan Pembangunan Kedah 2035 begin, the number of passengers is expected to increase linearly in the future. Next. Okay. The facilities that are available are one of double-story terminal building, where it is the main building where the passenger transfer between ground transportation. We have one of air traffic control tower, four hangars, one of fire station, two of runways, two of taxiway, and 500 of outdoor parking bays. Next. Okay, for our design concept.
Okay, Nazri, can you hold a little bit? Can we have Alia
Okay,
to present on this? Thank
thank
you.
you.
Okay, now. Hello. Dengar tak?
Ya, dengar.
So we move on to the design concept. So our design concept, this design concept is a very important aspect for Kedah, especially in the tourism aspect. The design of the airport terminal is mainly taken from the concept idea of the Changi Airport, Singapore, and also the Tamarin Square, Cyberjaya, with the concept of the green agriculture airport concept. So, as you know that our Kuala Lumpur William Airport is a domestic airport which play an important role in figuring green sustainability building into the architectural heritage. Tadi. So, as we can see from the building layout plan, the parking area incorporates the element of the green connectivity. So, the incorporating the green spaces in this urban area is not just adding a touch of the nature to the landscape. So, to, to maintain this sustainability, it is necessary to have the green roof system that many building structure implemented. So this green roof that we have been implemented in the terminal airport contribute to the sustainability efforts by conserving some of the energy by insulting the building and the mine clear the community, which reduce the need of the building. So next, the grass street player system also be applied to all the parking spaces within the development area. The grass street that will be used is the carpet block with the approximate size of 267 by 18 and 400 millimeter. It is to achieve the leadership in energy and also the environmental effects. And next, so the sustainability design. Next, so in this basic sustainability design, that we consider the consideration of the natural resources that occur at the site, such as the site and also the wind orientation. Which, for the building structure with the basic. So as we can see that the site orientation is important as it defines a method of fixing in direction of the plant in such a way that brings maximum benefits from the element of the nature. So the site location also placed based on the consideration of more sites that facing to the east and less sites facing to the west. So this will ensure that the maximum use of the natural sunlight and reduce the usage of the electricity. Next, so for the wind orientation also is play the important part in here. So as I can see that the effect of the wind on the takeoff and the landing. According to the relevant regulation and also the standard, it states that the aircraft should not land on the side of the wind or take off and land with the wind. So it is better to take off and land against the wind, but the heat point should not be too strong. So when we determine the direction of the runway, the guarantee rate should not be less than 95%, because as a true Malaysian meteorological department, the annual mean wind speed is 1.8 meter per second. So, and here it is why we oriented our design like this. Next. So, for the
Okay, thank you, Alia. Can we have Awad? Can you hear me? Can we have Awad?
But I think Awad is not here.
Oh,
Betul, dia tak ada. Oh, dia ada.
okay. Can we have Mirza here to continue?
Okay, so we now under sustainable features that are going to be implemented. Hello? Tak dengar langsung? Dengar. And now we are under
Tak dengar. Kenapa?
Doctor, I think lost connection. Can we proceed with Awad instead?
Okay. Yeah, sure.
Okay, Awad, you present this.
Okay. For sustainability future, there's three steps. The first one is before the construction, and before the construction, the topographical and geotechnical survey should have been done, and for the land clearance before rigging and access the track should be identified, and the affected surrounding areas around the site, our site will be limited, and based on the identified sensitive receptors surrounding the project site, attention will be given at the residential area in Taman Stadium Kerry due to its proximity to the project site. And also in this area, the best manager practices by adopting low vibration equipment by the project proponent, the appointed contractor during the construction period. Next, please. Here for the during the construction activity involving heavy machine, which has with the high noise will only be carried out during the daytime only, and the temporary jersey barriers with plastic hoarding will be erected around our project site active and also the active work area, especially in at the identified sensitive area, and all the equipment and machine will be maintained to avoid the emitting excessive noise, and also the development will be carried out in phases to reduce the generation of dust, and also the water truck will be used to reduce dust on construction road whilst wash through whilst wash straw for wheel washing while be used for vehicles coming into and out of the site. Next, please. And for the after the construction, green connectivity spaces will be implemented and incorporating green spaces in urban area is not just about adding a touch of nature to the landscape. The urban green roof or vertical greens and creation of water features are some approaches to be implemented to reduce the microlimit and reduce the temperature, and also the cumulative effect of such practices would bring greater ecosystem surface into urban area, such as to improving the air quality and reducing the warm storm water and mitigating the urban heat island effects. Next. Here are the geotechnical assessment. Next, please. Here I will continue to the airwork of the second for the earthwork analysis. The second one, the 2D and 3D contour. From the software, a lot of beneficial information can be obtained, such as a map contour, cut and fill, and more. Next, please. Here are the earthwork analysis, also detailed earthwork analysis that we have done were six sections produced for the earthwork analysis. And as you see here, the red color indicates the cut and the blue color indicate the fill. Next. Here are for the cut and fill analysis also. From the contour, we do six sections cutting. The proposed level that we have chosen is 21.9 meter. And from the software output, the value of the cut volume that we obtained is 13,664,217 meter cube, whereby the fill volume is 13,643,761 meter cube, and the net volume is then obtained by subtracting the cut and fill volume. So the volume that has obtained is 2,456 meter cube, and the difference volume is not that big, so it's economical. Next, please. And here, based
Okay,
on
thank you, Awad. Can I have Hafiza to continue?
For the geology of site and geological assessment, based on the geological map of Peninsular Malaysia, edition 2014, published by Director General of Mineral and Geoscience Department, DMG. The proposed site location is located on the River Coast, which overlay the bedrock consisting of schist, pyrite, slate, and limestone with minor intercalation of sandstone and volcanic. This is the layout plan of our airport. This is the investigation layout plan. We propose 8 numbers of boreholes and 60 numbers of the location are exception. This is a summary of the borehole profile. We propose 8 numbers of boreholes. The available SR report has only see here the cross section AA across the terminal building. Across the section AA at the terminal building to study the soil profile. This is the cross section AA across the 4 boreholes. Referring to the SPT result in actual SR report, the top layer can be classified as sand-based layer and the middle layer as silty sand. The bottom layer as silty sand. The bottom soil layer is sandy silt. The rock formation beneath is shale. The layering further justified by the SPT result. The top layer L1 is sandy silt with SPTN less than 10 and thickness between 4.5 meter to 9 meter. The second layer is a silty sand with SPTN between 10 to 50 and a thickness of 3 meter to 50 meter. The rock layer, the third layer is a silt layer with N larger than 50 and a thickness of 3 meter to 2 meter. The rock layer beneath is shale with RTD of 10%, which is highly fractured and highly weathered. This is the physical properties of soil. The plasticity chart is constructed based on the attribute limit test result. It shows that the majority is silt with plasticity ranging from low to intermediate plasticity. Clay is a minor or high to extremely high plasticity with only 3 out of 12 soil samples tested as clay. This slide, this shows the bulk density plot and dry density plot. The bulk density determined for the first layer is 18 kilometer per meter cube. Second layer is 19 kilometer per meter cube, and the third layer is 20 kilometer per meter cube. Moving on the chemical properties of soil, there is no track of acid attack, sulfate attack, or chloride attack. The soil is slightly organic. This is a summary of a direct shear box. The effective compression and friction angle for each layer is determined for each layer, which will be presented in the next slide. Here, this is a summary of the recommended geotechnical design parameters for layer 1, layer 2, and layer 3. This is a filing layout. The total number of 124 bore pipe are being proposed, consisting of single pipe and 2 pipe group. The bore pipes are 600 mm diameter. This is a pipe foundation detail. The concrete grade used for bore pipe is grade 40. 2 pipe design were proposed. One is for a single pipe, and the other one is for the pipe group. For the single pipe, the dimension of the pipe cap is 900. For the second pipe group, the dimension of the pipe cap is 900 by 700. This is the pipe design. The pipe cut design is done manually as well. It shows that proposed size for pipe cap 1 pass with main reinforcement size of 16 millimeter of 6 rebar. Okay, next is
Okay, thank you, Hafiza. Can we have Chipepe?
I will proceed with the erosion and sediment control plan. Here is the layout for the erosion and sediment control plan. We propose the wash-through at the exit road of the site. The sediment basin is placed at the lower level so that the sediment can flow into it and easily to be trapped. Then it will exit to the nearest existing drain. Also, the on-site detention pond will be placed at the lower elevation. ESCP is the temporary measures that will be implemented only during the construction phase in order to control the environmental impacts of erosion and sedimentation. Next. This is a summary of the proposed erosion and sediment control plan measures. The sediment basin is proposed to collect and hold the runoff, which allows the suspended particles to settle out before the runoff leave the site. So the proposed site for the sediment basin is 47-meter length, 15-meter width, and 2.2-meter depth. Next is the wash-through. It is a temporary wheel washing system installed at the exit of the construction site to prevent the sediment from being tracked onto the public roads. So the size proposed is 4.5-meter width and 9-meter length to fit all the vehicles type. On-site detention pond is also proposed for both water quality and quantity control. The size proposed for the on-site detention pond is 250-meter length, 500-meter width, and 5-meter depth. Next. Moving on to the structures design. This is
Okay,
the
can we have
basic
Mirza? Chipepe, thank you.
Hello, dengar. Okay, so this is the basic design information on structure analysis and the design. So the course of practice use Eurocos for the analysis and design and uniform building by laws mostly for loading value. So the design criteria is as shown. The design working life is in the category 5, which indicates 100 years of working life, as the airport is considered as a civil engineering structure. For the fire resistance for the airport is 2 hours for all elements, and the exposure class is moderate humidity. The unit weight of concrete used is 25 kilonewton per meter cube, and the load combination used is 1.35 GK plus 1.5 QK, and the concrete grade is the next. Okay, so these are the loading values obtained from EC1 and the UBBL. So the live load and dead load are tabulated as in the slides. Next. Okay, so this is our double-story main terminal building, which use reinforced concrete structure. The size of the terminal building is 81 meter times 36.7 meter. Next. So, so this is the layout of the our terminal of the airport. Next. So this is the architecture layout of the ground floor. So this is the architecture layout of the first floor of our airport. So in the design and detailing parameter, the beam and column size vary to achieve optimum and economical design. So the beam sizes used are 200 by 500 millimeter, and the column range from 300 by 300 millimeter to 350 by 350 millimeter. And all the slabs will be uh, 175 millimeter thick. Next, so structural analysis and design are conducted using Xteam software, and the 3D analysis model is shown as shown in the slide. So from the top of the left side, it shows the shear force diagram, and the right is the bending moment diagram.
and at the bottom one is the axial force on the column. Next. So this is the beam detailing. So this is the software design summary for the detailing for beam 1 stroke E 2E. So where the beam has the highest bending moment of 131.07 kilometer meter, and the shear is 61.81 kilonewton. The reinforcement size, which is in the diameter, range from 12 millimeter to 20 millimeter, and the deflection checks indicates that the beam pass. Next. So this is the analysis output for the column. So the steel bar column varies from diameter of 10 to diameter of 32. As shown in the left figure, the column is 300 by 300 millimeter on the first floor, which with the outer tie with steel bar diameter of 10 millimeter, and the spacing is 175 millimeter. So the right figure shows that the column size is 350 by 350 millimeter at the ground floor. So based on the analysis output, column 29 has a maximum axial load of 1661.7 kilonewton that is located on the ground floor. Next. So this is the slab detailing. So all the slabs are in 175 millimeter thick. So for the detailing slab A2 to A2 to 3, so we can see that the top reinforcement, the steel bar diameter of 10 with the spacing 250 millimeter. Next. Okay, so let's move on to the road and runway design. Next.
Okay,
So
Nazri, you take over this. Ada banyak lagi ke slide ni? Macam banyak je.
Ada tinggal sikit lagi, Doktor.
no,
Okay.
lajukan sikit.
Okay, okay, let's move on to the road and the runway design. Next, this is the road layout for our domestic airport. Domestic airport, which consists of two-ways road that are well designed for the airport users. All the roads parameters are designed in accordance with the Arahan Teknik Jalan 8/86, which is a guideline on geometric design of the roads. And the proposed road is classified as urban road with the design standard of U4, which the lane width is 3.25 meter, with the marginal strip width is 0.25, and the shoulder width is 3 meter. Next. Okay, for the pavement design for our proposed road is designed based on the Arahan Teknik Jalan 5/85, which is the manual on the pavement design. Based on the previous slide, this is the cross section of the proposed road of our airport, and to determine the pavement thickness, a lot of parameters have to take into account, such as the average daily traffic. Therefore, the thickness required for the proposed road is 50 mm for the wearing cost, 150 mm for the binder cost, and 200 mm for the base cost, and 200 mm for the sub base cost. Okay, next. Okay, for the parking layout, here is the parking layout of our airport, which is for our domestic airport. The parking are designed based on the minimum length and width of the parking for each type of vehicles that can be determined. So for our airport, the total parking available is 523 in total unit of parking. Next. Okay, this is the signage that will be installed after the construction is done, and there are stop signs that will be placed to assign that right of the way at the intersection, and to make sure that traffic flows smoothly and predictably. The bound section is used to sign the warning of the sharp rise in the profile of the road, The speed limit is set to 40 km per hour at the parking area, and the junction sign also will be placed to show that the direction of the road. And the parking signage will be placed at the parking area for sure, and the no stop sign will be placed near the terminal to prevent the congestion in the front of the terminal. Next. Okay, for the traffic management plan, TMP was designed to identify the way the activities on the road will be carried out. So it can minimize the inconvenience and to ensure that the road users and the worker remain as safe as possible. It provides enough temporary signs to ensure that the surrounding site is free from hazard and to protect the road users from any obstruction. Next. Okay, here is the summary of our traffic impact assessment (TIA), and the proposed development is located near to the residential areas. It is governed by the Majlis Perbandaran Sungai Petani (MPSP), and the road type for this is three-way junction road, and the road that located is at the Jalan Kuala Kecil, Sidam Kiri, Kuala Muda, and the type of the carriageway is single carriageway. The lane for this width with the width is 7 meters because it is a dual lane road. The level service is assumed to be B, which the volume per capacity ratio is about 0.41. The traffic condition is in the stable flow and operating speed beginning to be restricted somewhat by the traffic condition. And from this assessment to improve traffic, proposed junction medication of the existing with the provision of physical curb or the median at the approach of the junction to prevent the illegal turn movement. Also, we want to propose install the speed sign to reduce the speed of the vehicle at the junction of the existing road. Next. Okay, let's move on to the road to the runway design, where the design of the runway is based on the Federal Aviation Administration guidelines, where there are codes number and the code letter that must be determined in order to obtain the runway width. So based on the guideline, the width on the runway obtained is 45 meter and the shoulder width is 50 meter. Okay, next. Okay, this is the cross section of the proposed runway. And the design for the runway pavement thickness is based on the Federal Aviation Administration guidelines too, where the runway requires the stabilized course, which since the maximum takeoff weight of the design of an aircraft is more than 100,000 pounds. So our final runway pavement thickness is 150 mm for the bituminous surface, which is the polymer modified asphalt, 200 mm for the bituminous bound base, and 250 mm for the sub base. Next. Okay, for the runway marking, this is the detailed drawing for the runway marking, which is all the marking are also designed based on the FAA guideline. Basically, runway marking are important as it will provide information that is very useful to the pilot during takeoff and landing. Next, the uniformity in runway marking can enhances the safety and improve the efficiency. In general, the markings for runway are white and yellow for the taxiway. Next. Okay, for the here is the drainage layout plan where the water.
Pepe, you take this.
Sorry. This is the drainage layout plan. The water will flow from a high elevation to low elevation, and eventually it will end up flowing to the existing drain. The break sumps are added to the drainage when the water changes the flow direction. Next. This is the example of the drainage design with a stainless steel drain cover. The drainage type is the U-drain channel. The main purpose of a channel drain is to remove the surface water away from this proposed site. So this will help to prevent flooding and overspill. The material for the proposed drain is precast concrete. This type of drain will not buckle and is resistant to corrosion. And this is the proposed drainage size. For the main terminal building cargo hangar, drain size 600 mm are proposed. Next, for the parking, control tower, and fire station, a drain size of 450 mm is proposed. For the runway, a drain size of 900 mm is proposed because the flow at this area is higher than the others. Next, this is the layout plan for the water reticulation. The design of this system is based on the guidelines from the Suruhanjaya Perkhidmatan Air Negara. The proposed pipeline is high density polyethylene HDPE with 200 millimeter diameter. HDPE pipe is selected because it's low weight and long-term cost effective. It is leak-free joints and corrosion resistant. The proposed pipe diameter has been validated using the AirPlanet software. The storage tank will be placed above ground with the capacity of 20 with the capacity of 225,400 liters per day. According to Kaedah Industri Perkhidmatan Air 2014 Perkara 50, it is a mandatory requirement for the water tank to be built for 2 days capacity. The cylinder water tank above ground is designed because it is easy for maintenance. Next. The water demand for each airport building is calculated according to Table B1 of Uniform Technical Guidelines, Water Reticulation and Pumping. The purpose is to increase the water availability and consumption of water usage for the airport. The total demand for all of the buildings is 112,700 liters per day. Next. Here is the network map from the AirPlanet software. The analysis of the water flow network is carried out based on the Hazen-Williams formula. The Hazen-Williams coefficient used is 100. The tapping point of the project is assumed near to the main road with a pressure head of 27.5 meter. The water will be supplied from the pipe of the tank and distributed to each unit. The nodes are placed at each unit that have water flow and consumption. The pipe will be placed at 25 meters below ground. Next. This is the pipe network analysis. The pressure for each node is 15.83 pound per square inch. The water flow in pipe 1 and 2 is greater than others because of the velocity. When the velocity is high, the water will move faster, so the flow rate will be increased. So from this, we can see that the greater the flow, the greater the rate of head loss. For the flow rate, it can be observed that when the flow rate increases, the friction factor will decrease. It is because when the flow increases, the viscous force on the walls of the pipe
Lama
will
lagi
be
ke?
reduced.
Lama lagi ke Nazri?
I think
Lagi sikit doktor.
Sikit berapa banyak? You are already over 40 minutes.
Dah sejam dah ni.
Okey doktor. Start lah.
Cepat sikit
Next is the layout of the sewerage reticulation system. The sewerage design follows the guideline from the IWK. The sewer pipe is connected to the nearest water treatment plant, which is Kuala Ketil Water Treatment Plant. The sewage will flow and discharge to the existing manhole near the main road. Next. This is the sewerage detail. The sewer pipe will be placed underground to transport the wastewater or sewage from buildings to the treatment plant for treatment. The proposed sewer pipe is UPVC with 110 millimeter diameter. UPVC pipes is selected because it has high tensile and impact strength with the pipe velocity is 5.98 meter per second and the pipe flow is 0.06 meter cube per second. Next. This is the longitudinal section of the sewerage system. The fall for the manhole is 0.1 meter with a starting depth of 1.2 meter. To get the inward level, the proposed road level is minus to the depth. The inward level will decrease as the depth increases. Next. This slide is about the manhole details. The PE for airport passengers is 0.2 passengers per day, and for airport employees is 0.3 per employee. So the population equivalent is 840. The type of manhole is precast concrete with the number of manholes is 36. The manhole cover is ductile iron with the size of 840 mm times 840 mm times 100 mm thick. Next. Moving on to the cost estimation and
Okay.
project management.
Change. Siapa lagi tak? Awat.
Yes, Doctor. For the cost estimation, for cost estimation and project management, we estimate the total cost of Kuala Muda Kulim airport with the sustainability future is about 305 million. Next. Here we will show on the summary of the cost estimation with the similar project. This is where we use Sultan Abdul Halim Kedah Airport as our reference for our estimate cost. Next. Here, here are the general overview of the work management of the Gantt chart, which will be summarized in the next slide. Excuse me. Can you next? Next, please. Here there are seven milestones for this project, which are the planning phase, preliminaries work and survey work, and pre-construction phase, and site parameter and earthwork, and construction phase and closure phase. The activities are linked to each other, and the distribution of work followed the work breakdown structure and duration to avoid construction delay. In any case the where the project encountered a tight schedule, a referring process of work breakdown need to be delivered and rolling wave planning are considered. Next. For the cost analyzing, the analysis ROI and back period is depending to the total review and the total net profit of the development once operation, and the project return to on investment ROI without sustainability features as showing is 13.41% and 13.31 and 13.41% respectively. And for the payback period, it takes about 10 months for the investment of the project recover, and the duration is the same for investment for without sustainability aspect. With the sustainability aspect, it's more for aviation sector to have payback period for longer than 10 months because the number of passengers is increasing every single year. And a short payback period means the investment will be repaid shortly. In other words, the cost of that investment will be quickly recovered by the cash flow, and that invested will generate. Next. Here are our total revenue of the project, which when our project is planned to be complete at 2024, and it's planned that outbreak will probably on more COVID-19, and therefore the such revenue will be gotten per year with the project completed. Here the sustainable creating a product and service that consider the environmental, social, and economic impact from the initial phase through the end of the life, and for the cost effective, the provide value engineering works to client in order to provide the most cost effective design in all aspects of the engineering works. Next, please. Here is for thank you. That's all for us, and thank you.
Okay, thank you very much. Group number 8, Teras Maju. Now I would like to invite Professor Madia, Dr. Helmi, and also Dr. Izian for the Q&A.
Assalamualaikum. Dengar?
Dengar.
So, saya tak tahu saya yang gila tu you all yang gila. You know, you have submitted to me a report with an appendix 1,661 pages. So what do you expect me to do? You want me to read through all the appendix? 1,000 bukan 100, Dr. Shah. 1,000 pages.
Actually, for
Salah ke?
1,000, so that is the appendices to that from analysis from the esteem software.
So, semua benda ni semua you bagi kat saya. Semua yang keluar dekat esteem semua bagi kat saya. Saya tak tahu mana satu saya nak tengok. Okay, second question. I thought you have the green roof in your building kan? Last time.
Yes, doctor.
Mana? The green roof tu. The one that you know, you said you want to do the green roof.
Yes, doctor.
Dekat dalam your structural design. Kat mana tu? The green roof tu semua ke? On the top of your building?
No, doctor. Only at the above the ground floor, which is the first floor slab near. I only put it the front only, not all the floor.
Okay lah, but in your structural design, This is like a lobby roof kan? Lobby roof.
Yes, doktor.
But in your structural design, where is the lobby roof? I cannot see the lobby roof here. Kecil sangat. Ni
Kecil je
ah.
doktor. Only 2.5 meter.
I know 2.5 meter, but ni the bottom left one, the blue yang blue color tu, mana? Where is the roof? Where is the green roof tu?
Oh, this in this layout, this is the ground floor. For the first floor, I did not put it in the slide.
Kenapa tak letak? Okay, in the 3D design pun saya tak nampak. Mana ada tu nampak kat situ? I don't know. Dia macam tak nampak.
Ya doktor, tapi kecil je.
No, it's not kecil. It's tak nampak. Saya tak nampak ada perbezaan. I should see because I can see a line of column and footing there that indicates the first facade lah kan. But where is the extension of the another column of the lobby tu? Lobby tu tak ada column eh? You don't have column
Tak
on the
ada,
lobby.
doktor. I did
Apa
not put
pasal
the
you letak
column.
pokok tak ada column? Jatuh ke? Cantilever? Huh? You put the slab and then you don't have column. And then you letak pula pokok. Kan pokok runtuh, bukan tanah runtuh, pokok runtuh. Okay, so that one.
Okay, doktor.
Alright. Okay, then. Sudah kan? Okay, and then for the foundation, you submit to me the appendix of manual calculation. This one is using Excel lah kan, the file cap design and so on. Okay, I'm referring to page 51 in the appendix. Okay, this calculation or the design that you have submitted here is not correct. Okay, there is some value that I need to see and check, but the value in the cell of this Excel say it is not applicable. Okay, and I do not know how much is your moment, and I don't know how much is your AS required. Okay, all that you have here is AS provided only. So what you expect me to do? To check? How do I check?
Sorry, doctor. I didn't notice that. I will check on that.
Okay, so saya pun tak tahulah kalau saya tengok macam ni, so maksudnya tak payahlah pun nak design kan. Okay, so there are many values that I need to check and compare, but I cannot see. It is not applicable there. Okay, so that is all from my side. Thank you very much.
Okay, Dr. Helmi, please. You have question?
I got no questions.
Because this is like during a training calendar.
Okay, Dr. Helmi. Siapa during the presentation by Mirza tadi tu, I saw there is one slide with too many columns. Is it the right one or yang mana kalau boleh tunjuk slide yang banyak columns tadi tu? This one. How many columns that you have? This is for the first floor. Who did this?
The whole terminal building, doktor.
The whole terminal.
First floor,
So
yes, and second floor. Ground
the
floor and
first.
first floor.
Okay. I don't know whether this is right or wrong, right? But for me, I think that there's too much column here in the floor. That if you go to the airport, you tak nampak pun banyak floor basically kan. Banyak column. Floor tu okay.
Column.
Columns. That's why I'm not sure whether this is something like uh logic or not logic or okay. So this is some part things that you have to think about lah. And then I just realized that you have this. You want to also put the plant on the roof. Betul kan tadi tu?
Yes, sir.
Okay, but
Yes, doctor.
I have not seen any what type of plant that you want to put it there? Is it just a
Oh, okay.
grass? And then how are you going to put the layer of your soil on top of the grass on top of the roof? And then you have to think about it should have the additional load lah kan to the building. Anyone can answer that?
Yeah, actually we when designing using Steam, we already like apply all the loads from the soil because we already consult with Dr. Izian, and yeah, all the loads we already put into consideration when using Steam.
Okay. So that is fine. I'm okay with that. No problem.
Okay.
May I know what is the pressure at the tapping point? Your water tapping point, what is the pressure?
Um, 14.2 PSI.
14
0.2.
at the tapping point, yeah? Iya kah? Betul kah, Fiza?
Betul. Betul.
Where did you get the value from?
From software.
Software. No, it should be the input value lah from the software. Because you want to check what is the pressure that of your water at the terminal building, at the apa lagi tadi tu, tower, kan? So the first thing that you have to check is what is the pressure at the tapping point. So if the pressure is insufficient to carry the flow to your terminal building, then you require to have the pump. And I saw that you also propose to have the above ground storage tank.
Yes, sir.
So you need to have the pump also to take the water from the tank and
To the
deliver
building.
it to the terminal building. Am I right?
Yes.
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 We have.
So what type of pump that you are using here? Okay, you have to check that what type of pump that you want to include because you have the above storage tank there. Okay. From your EPANET software, what is the velocity that you obtain in the pipes?
0.07 and 0.06.
Okay, I think that is too low.
Maybe
But
because of
but
the
as long as it
elevation.
but as long as it is not exceed than 2 meters per second, then that should be
Yes.
okay. And then I heard also Chi Pepe mention about the Hazen-William coefficient that you use is 100, yeah?
Yes, sir.
Why you use 100? As far as I concern, using the uniform technical guideline from the Spania, because you are utilizing the HDPE pipe, so your Hazen-William coefficient should be higher, which is 120. If you are using the ductile iron or steel iron pipe, then it's okay to you to have Hazen-William value of 120. So what is the head loss that you obtain from the computation per 100 meter length?
0.05. 0.05.
Oh, very low, huh?
Yes, sir.
Very low. Okay. Any question more, Dr. Izan, from your side?
I have one more.
Okay, please.
It is regarding the road design. Okay, the road design calculations that has been submitted here, saya tak tahu where is the load design calculation is. Okay, because the one that I see here is like table, you know, reference from the JKR. Where is the actually the calculations, like, you know, you have, you know, I pun dah lupa actually Dr. Rizal how to design the road. Okay, but I'm sure there is a calculations and so on, how to get the thickness. From the calculation, you can, you know, provide the allowable thickness, you know, allowable layers and so on. Okay, but I cannot see that calculation of the design there. I'm not sure if they use the software ke apa ke. Okay,
No, Doktor.
ke
We
you
refer
dah
to
nampak?
arahan teknik jalan by JKR, and a lot of parameters have to be considered, such as the traffic growth and so on. And based on the CBR and the JKR, give suggestion to do the thickness.
Where is that statement?
What, Doctor?
Where is that statement appear in your report? Like, you know, like that is the suggestion one, because from the appendix I can see all the references, the jadwal and so on. You know, like when you want to submit your design, you should have that calculation ataupun apa nak cakap, semacam summary lah kan. So macam mana saya nak tahu, oh, this one is the thickness dan sebagainya, mereka ada dekat dalam page mana-mana.
Saya terlupa letak summary. Tapi dalam calculation semua ada. Cuma summary of the thickness tu saya tak letak.
Kan?
Tinggal summary. Tapi calculation on to get the thickness tu saya dah letak kat atas tu.
Kat atas tu dekat mana?
Dekat je kan.
Dalam appendix ke dalam apa?
Appendix.
Tak tahulah, road lain kan? Runway is different one kan?
Yes, betul.
Road design. Road design
Road
sampai
design
tak
saya
ada.
refer JKR. Yang runway saya refer FAA.
Yelah, even though you are referring to JKR, you kenalah bagi tahu apa benda yang kan. Maksudnya the design part tu macam lacking lah. Yang saya nampak jadual. Saya tak tahu mana satu sebenarnya. Saya nak guna thickness mana ni.
Yang doktor tengok tak yang page 10?
Page 10. Lepas tu?
Okay, so based on yang kita dapat kat atas tu, subgrade CBR minimum is 12.1. So falls under SG2, so the thickness Estated
Yelah, that one. The one that you said just now. That sentences. Mana saya nak tengok dekat dalam report you ni?
Oh, okay. Okay, I will summarize.
Faham tak? Takkanlah you nak suruh I pergi arrow ni, daripada arrow ni pergi pula rectangle ni. Tak tahulah apa benda saya nak buat ni. Apa benda nak rujuk pun
Sorry,
tak tahu.
Doctor.
Apa benda nak tengok pun tak tahu. Okay, so please
Okay.
Thank you.
Okay. I just want to know why you have this detention pond in the project. Nazri?
So as I already learned from my internship experience, the detention point is actually it will going to cater, which is this kind of point going to be constructed during construction, which all the water inside the sites going to be aligned to this detention point, and then this type of detention point going to have like GPT, gross pollutant trap, and all stuff, and then before it going to be out to the stream flow.
Is it a temporary or permanent structure?
This type of detention point is actually temporary, but some of the development, these are like for my experience from my internship, there are a lot of detention point, and some of the detention point going to be like to be permanent there, because it's going to be like a recreational park and like that, like macam tempat jogging ke like that, which is depend on the development, whether they want to apa tu, like the temporary of the detention point, or maybe they want to build it as a permanent.
So if you want it to be a temporary structure, then why you propose to have the wet sediment basin? It is also a temporary structure.
The wet sediment basin. Wet sediment basin, OSD. Tak nampak jap. So should we build the dry one, is it? That's your question, is it?
Yeah, if you want to control the sediment during the construction process, then you just need to have the wet sediment basin sudah lah.
Or rather than have the OSD lah.
Yeah, detention pond tu selalunya dia, most of the time dia akan jadi permanent lah, macam you cakap tadi tu. It's a wrap shape to cater the storm water if it is flowing into the pond, and boleh lah.
And then discharge to the stream flow.
Yeah.
So for this type of development, we don't need the OSD point.
I don't know. You are the engineer. You have to think lah whether it's supposed to
Okay. Faham.
Okay.
Okay.
Okay, but from the report that I just reviewed, I still have not see any calculations. How did you determine the apa tu, some sort like the total volume of your wet sediment basin ni kan? I don't know what is your time of the concentration. I don't know what slopes that you consider.
The time concentration I use is 20 minutes.
20 minutes,
Yeah, yes, sir.
So you calculate using what formula?
Time concentration.
Saya tak nampak itu formula itu di situ, di dalam report you. You have to show me lah that one, ya. And if your construction period is 2 years, then what would be the design storm yang you akan pilih? Is it a 3-month ARI? Is it a 5-month ARI or 6-month ARI? So on and so forth. That's all the all the parameters that you need to include lah in the design of your temporary wet basin.
Temporary wet basin.
Okay. Saya rasa kan, I don't know, this is my my opinion lah kan. You sepatutnya kena hadam tu span punya buku tu. Ada 200 pages tu manual span tu. Dalam tu semua dia dah tulis actually. The size.
Betul, doktor. The size proposed like that, doktor?
The size, and then if you have the for example, you have to propose.
The example of calculation.
Yeah, you have to show the tables of this reticulation system. Berapa pipes details you, berapa pipe notes you, and then each of the pipe details tu ada dia punya velocity berapa. All those information can be obtained from IPANET software sebenarnya. Okay?
Okay.
Boleh ya? So if there is no further question from the other supervisor, I think we should stop here lah.
I don't have anymore.
Dr. Izan tak ada. Dr. Hilmi, you want to add more ataupun okay?
Okay, semua okay.
Okay.
Should we mark your report based on the one that you have submitted, or you are going to resubmit the new one?
You're going to resubmit later.
By Monday lah ya.
So
By Monday.
same due date
Okay.
Thank you very much.
So,
Assalamualaikum.
okay.
Yeah,
Thank you,
Nazri.
doctor, so much for. Okay.
Thank you so much, doctor.
Okay. Alright. Thank you all. Thank you. Take care. Take care.
Thank you, doctor.
Assalamualaikum warahmatullahi
Doctor,
wabarakatuh.
nice day.
Okay, thank you. Bye. Assalamualaikum.
Doctor. Gambar. Oh, gambar. Kita buka.
Lah, ada tutup dah.
Tu Dr. Syah pun ada lagi.
Ya, udah tutup dah. Kita buka.
Doktor, jom tak gambar tu.
Tak tahu. Lupa.
Ya Allah, ada juga.
Kau tak kat orang dia nak tinggal ke ni? Boleh tak?
Tak nampak benda. Kita orang pergi sana.
Tepi mai sini tepi. Gelap.
Habis dah weh. Aku nampak awak.
Okay. Oh, saya belum leave ya. Saya ingat saya sudah leave.
Ambil gambar lah doktor.
Gambar. Boleh. Nanti saya buka kamera sekejap.
Doktor macam nampak letih.
Bukan lah
Doktor.
ni, tak kena.
Ayolah, kau present tadi tu 1 jam. Kenapa aku dengar je?
Bukan doktor, tadi lost connection.
Lost connection, doktor. Hujan. Tiba-tiba ribut masa kita nak present.
Saya dengar lah tadi tu.
Okey
Sudah
kan,
makan?
present?
Semua sudah makan?
Belum makan doktor. Saya tak tidur. Semalam tidur pukul 6.
Sama.
6 petang.
6 pagi doktor.
6
Bangun pukul 8.
Kita orang stay out, doktor.
Macam mana kau tidur pukul 6 pagi, kau bangun pukul 8, kau subuh pukul berapa?
Solat dulu lah doktor.
Kita
baru
solat
tidur.
dulu baru tidur. Macam tu.
Doktor ingat tak solat ke? Allah doktor.
Saya tanya, janganlah marah awak ni.
Doktor, kita orang present tadi
Okey tak,
okey ke
doktor?
teruk sangat doktor?
Doktor bagilah markah
okey.
lebih.
Tak okey doktor.
Doktor.
Tapi doktor tak tanya root pun. Kalau doktor tanya root, saya boleh jawab semua.
Sebab tu saya tak nak tanya. Saya tahu awak yang buat root tu.
Doktor patut tanya saya tu. Water lagi.
Okey, so tapi begini, saya maksud dia kita expected banyak design punya elemen lah yang you akan present untuk second stage ni. Kita dah tak nak dah tahu konsep-konsep tu apa sustainability tu dah tak nak dah. Bukan you dah present dah dulu tu kan. So element of design tu macam tak berapa nak nampak dekat dalam you punya ni. Macam geotechnical tu saya tahu CPP yang buat tadi. Saya tahu dia yang buat semua tu. Dia geotechnical punya elemen tu dia punya discussion tu terlalu panjang sangat. Macam there are things that you supposed not to present lah. Tak perlu pun sebenarnya. Chemical tu apalah tak perlu pun semua tu. Okay. So bila kita dah tahu you punya soil profile, kita nak tengok macam mana you design the foundation tu. Itu dia punya key dia tu.
Faham?
Macam pizza pun present pasal water tadi kan. Nan hado je aku tengok dia punya pipe tu tadi. Berapa kerat je yang adanya. Kan? You tak tunjuk pun you punya sewer pipe tu dekat mana you letak. Bawah jalan, tepi jalan, atas jalan.
Ada mention lah doktor.
Bawah jalan lah.
Bawah jalan dah mention dah.
Ada ke?
Ada lah doktor.
Ada doktor.
Ada doktor.
Berapa meter bawah jalan?
20.
20? Allah.
Tak doktor.
Kan? Macam pelik saya tengok awak punya ni kan. Pressure head dekat tapping point berapa?
Pressure head tu 27.8 something.
27.5.
So pressure head dekat tapping point 27.5. So air tu nak masuk ke dalam tangki tu berapa tu?
Dekat pump tu. 10.
Tapping point go to our tank.
Storage tank tu sepaham saya lah kan. Yang storage tank yang you nak buat tu dia adalah untuk store water kalau ada emergency je. Dalam setiap terminal building tu ada toilet kan?
Ya doktor.
Itu must also have the apa they call it cistern tank. Untuk individual unit tu juga. So pressure dekat cistern tank tu berapa?
Dekat building tu.
Berapa?
13.
Building awak berapa tingkat?
2.
Height dia berapa? Height building berapa?
Height building berapa? Height 12 meter.
You ke? Tadi saya tengok 37 meter awak tulis dalam slide tu.
Itu ni doktor.
Terminal.
Lebar dia.
Bukan 81 ke lebar dia?
Oh, panjang.
Oh, 30 lebar. Panjang.
Lebar tu panjang dia, belakang itu doktor.
Okay. So tinggi dia 12?
Ya. Well.
So maksud dia 12 meter lah dia punya pressure dia kan kat situ? So yang kat pump tadi 25 So maksud dia boleh je lah air tu pergi masuk ke dalam tangki tu. Tak perlu pun ada storage tank tu pun sebenarnya.
Faham. So from tapping point tu boleh je terus masuk ke apa? Macam
building.
Cistern tank kita panggil.
Dalam building ni.
Oh, faham.
Astaghfirullahalazim. Pressure head tu adalah menentukan pressure lah, ketinggian kan. Sebab tu saya kena tahu berapa pressure dekat tapping point tu dulu. Kalau pressure tu low, katakan berau 8 meter ke tak sampai, ada barulah you kena pakai pump untuk sedut air tu masuk ke tangki. Gitu je awak pun. Tak apalah. Saya pun dah nak balik dah, penat dah rasa.
Ya, doktor nak tak gambar?
Ya, jom.
Ya, doktor. 1, 2, 3. Okey, doktor dah.
Sign depan face to face ya. Perkeliling dah keluar tadi.
Memang starting terus face to face, doktor?
Kalau saya baca ni, dia kata PDP in the Faculty of Engineering will be conducted physically in the second semester of 21-22 session.
Tapi saya depan dah tak ada subjek doktor.
Oh, doktor tak nak ajar kita lagi, doktor?
Wah, awak nak jumpa saya buat apa?
Doktor. Saya depan dengan Dr. Wali. Dr. Wali lah, water treatment. Dr. Z. Z solid waste.
Oh, baru belajar water treatment ya, sen depan? Patutnya kena belajar semester ni ya, water treatment dah.
Tapi masa environment dah belajar sikit dah silap masa environmental engineering. Ya.
Tapi tak detail kan. Kalau ni lebih detail lah.
Tahu macam proses lah.
Environment tu dia banyak kepada treatment plant itself.
Ya. Saya suka environment.
Okay ya. Terima kasih Jaga
Thank
diri
you,
masing-masing.
Thank you, doktor.
Bye-bye Cik Pepeng.
Have a nice day. Thank you, doktor.
Assalamualaikum.
Waalaikumsalam.